Okay, so let's look at number 4. You're asked to determine the x-intercepts or the horizontal intercepts, and we would do that the same way that we did when we were working with our quadratics. And when we were working with our quadratics to find the x-intercepts, that is when y is equal to 0. So we're going to substitute in 0 for our output. And then we would have x over 1, x minus 1 over x squared minus 3x minus 10. So one way to do this is we could cross multiply. Okay, we could multiply both sides by x squared minus 3x minus 10. And then over here, whoops, x squared minus 3x minus 10 times 0. Well, this is just going to be 0. These will divide out, and so I'll have 0 is equal to x minus 1. Then x would be equal to 1. So here my x-intercept turns out to be 1, 0. So really, when we have rational functions, to determine the x-intercept, we just set the numerator equal to 0. So again, to find the x-intercept, set the numerator equal to 0 and solve for x. So kind of a clue, anything I have in red there is kind of an important thing. So to determine the y-intercept, just like we did with our quadratics and linear functions as well, to find the y-intercept, we plug in 0 for x. So here we would have f of 0 is equal to 0 minus 1 over 0 squared minus 3 times 0 minus 10. So we would have negative 1 over negative 10 is equal to 1/10. So there our y-intercept is going to be 0, 1/10. So again, to kind of reiterate that, to find the y-intercept, plug 0 in for x and evaluate. Next we'll want to find the vertical asymptotes. We would want to set the denominator equal to 0 and solve for x. So I'll do that. I'll have x squared minus 3x minus 10 is equal to 0. And then I get to use my factoring skills again. So I have x minus 5 is equal to x plus 2, and set each factor equal to 0. And then I would have x is equal to 5 and x is equal to negative 2. So that means I would have vertical asymptotes where x is equal to 5 and where x is equal to negative 2. Now, what happens to the graph as x approaches positive infinity and as x approaches negative infinity? Well, again, since the degree of my numerator is less than the degree of my denominator, okay, so the degree here is 1, the degree here is 2, so my denominator is greater than my numerator, then they will eventually, the function will eventually approach 0. Because that denominator is bigger, it's going to overtake my numerator, and after a while, this stuff won't matter. Let's look at number 5 now. So we have h of x is equal to x minus 4 over x squared minus 16. Now, it's asking you where would you expect to have a vertical asymptote. Well, based on what I've told you so far, we would set that denominator equal to 0 and factor. So if I factored, I'd have x minus 4 and x plus 4. And if we graph this, let's go over to our calculator. And by the way, you want to go back and graph number 4 too, just to kind of confirm what you found. But if we graph this one, we will have in parentheses x minus 4 divided by parentheses x squared minus 16. And again, based on our algebra over here, we would expect to have asymptotes at 4 and negative 4. So let's see what our graph looks like. So here, that's our negative 4, but it doesn't look like we have an asymptote over here at 4. Let's see what we find out on our table. Let's go table set, and we'll start at 0, and we'll go up by increments of 1. And then we'll look at the table, so we'll go second table. Alright, so down here at negative 4 we have an error, which is that's what we would expect, because if we put negative 4 in for x, negative 4 squared is 16 minus 16, that gives me 0. So that seems right. Let's go over here to my table again and look at 4. Well, we can see at 4 we also have an error, and that makes sense because if we put 4 in for x, we get 4 squared is 16 minus 16 is 0. That gives us 0 in the denominator. Well, why does our graph look like this? This is kind of an interesting thing about rational functions, is let's take this rational function and we have x minus 4 in the numerator, and let's go ahead and factor the denominator. We have x minus 4 and x plus 4. And you can see that we have x minus 4 both in the numerator and the denominator. So what we can do is we can say we can divide out factors. And x minus 4, those are factors, so we can divide those out. So what our graph is going to look like, it's really going to look like the same graph as 1 over x minus 4. Now we can go over to our calculator and kind of take a good look at what that looks like. Take a little mental snapshot, and then let's clear that out and let's just put in x divided by, again, parentheses, x minus plus 4. Graph that, and that's what our other function looked like. But if I look at this, if I look at the table, I notice something kind of interesting. I have a value at 4 here, but I don't have a value at negative 4. Negative 4 is still an error, because here if I put in 4, I would have 1 over 8. So getting back to this situation here, I have to kind of explain what's going on at 4 in this situation. Okay, I know I have here at x equals 4, this is a vertical asymptote. But here at 4, it's just undefined. So we say at that point, because these divide out, that there's a hole in the graph. So if you factor the numerator and the denominator, and then something is able to divide out, then you will have a hole in the graph at that point.